Hey everybody! Last night of content. So I hope this recording finds you safe, practicing your social distancing, and if you're on those front lines, again, we're thinking of you and hoping that things are going well for you. So this one will be short because the concept you already understand, or at least I hope I understand. It's just an extension on the confidence interval our lesson we did last week. So last week we focused on sample means. So we have a mean of a sample. So remember, you add them all up, divide by the number, that gives us the mean. And we build this estimator or estimate tool that tells us kind of where we could expect the population mean to possibly fall. Tonight we're going to focus on proportions. And proportions are just a percentage. It would be a binomial situation. You have two choices, and it's either success or failure. And we'll be using percentages. So we'll use decimals, and things will change a little bit, but for the most part, they'll be very similar. So I'm going to start off the lesson with just a review of the z-score and the t-score. I have a number of questions at the end of the thing. There's 3 questions at the end of the quiz that refer to, 2 questions that refer to Z and T-score and when to use them. So last week we introduced the T-score. And the things that you need to remember about the T-score is we only use them when we're working with the sample means. So that would be a chapter 8 question. So that would be build a confidence interval for the sample mean type question. Okay. The other thing is, so you got to first know that you're doing sample means, and then you have to look at your population standard deviation. And I see I have a mistake in my slide. Population standard deviation right there. So when you know your population, don't know your population standard deviation, and you only have your sample standard deviation is when you use a T. Okay, so you have to look real close. So when you look at the quiz answers, if you already looked at them, go back and look. I put notes in there, circled things like population standard deviation or sample standard deviation to make sure you're focusing on those in these questions. The nice thing about tonight's lesson is you don't have to worry about T. You'll always use a z-score. So we have our list of z-scores that we produced last week that you'll use for your confidence intervals. Okay. So tonight's is about proportions, and that's our point estimate. So remember, point estimate was our best guess, and for a sample standard deviation, for a sample mean, that was our best guess for the mean. Tonight we're going to talk about percentages. So it can be given as a percent, like 45%. It can also be given as a number of successes out of a total. So 7 out of 14. And then we'd rewrite that as 0.5. And the 45% we'd write as 0.45. So we'd rewrite those values that represent a percentage as a decimal. And then we'll use that decimal when we produce our confidence interval. So the next slide shows an example of that point estimate. So we had a large survey. People would rather drink bottled water rather than tap water. If you live in the city of Marion, that's probably the case for most of you. So you would actually take the number of successes divided by the total number of ways, and that gives us that estimate, all right, that point estimate. Now, the calculation, you're going to need 1 minus that estimate, right? The 1 minus P. And so you'll notice I found it here also. My advice is when you're doing this is to find both of those separately. If you have to find them. If you don't have to find P by dividing, if you're just given the 0.63, go ahead and do the 1 minus P so you have it. Doing the subtraction inside of the formula in Excel can get quite messy. Okay, so you're going to have some type of percentage. So on 7 of your problems, you can anticipate either be giving that 0.637. You might be given the numerator and denominator of that fraction. Or you could be given it as an actual percentage. So just like the confidence intervals for the means, we have a couple pieces that we need to have. One, we need to have the mean. And so for proportions, we call the mean P, sometimes referred to as P hat. but that's your point estimate. That's what we found on the previous slide. The second thing is your standard error. And so the standard error, okay, well, it's not quite sigma, but it is it's kind of like our sigma divided by the square root of n. You'll notice that we have a large square root, and inside that square root, we take p times 1 minus p, and we divide that by n. And when I type this into Excel here in a little bit, you'll see it's not difficult to type in. You don't have to have any extra parentheses or anything like that. It actually goes, it goes in pretty nicely when we do see that. So if we put that together, the two pieces together, and we include our z-score, you'll notice that we have our point estimate. We have the -1. We have a z-score, and the z-score is found just like it was last week. So you're going to look at your confidence level and you're going to determine what z-score you'd use. And then you have that standard error piece. And then remember, everything after the minus or everything after the plus is exactly the same. That is what we call our margin of error. Okay, so everything after the minus or after the plus, or if you see them both together, the plus or minus, that is what we call our margin of error. P is going to be in the middle of that. You're going to add a number to it. You're going to subtract a number to it. It's going to give us that interval. So if we go back to the water bottle example, so we had that 0.637, I believe that's what it was. And then you had your 1 minus P, which is 0.363. And then we have a 90% confidence interval. So we have to remember what z-score that we need. So we need a couple things. So I'm going to go to Excel here and let's type in the things that we need to have. So we need to know P. Tighten this up here a little bit. And I already did the calculation for P. So I'm just going to type that number up here. That was 0.637. I need 1 minus P, which is 0.363. I need to have, I need a z-score. I need n, don't I? I need n. N was the 1361. And then I need a z-score. Okay, and remember the z comes from inverses. So, for example, if my confidence level was 90%, then I would have done an inverse, norm inverse. And I would have done the percent left of one of those lines. So I could have done the point, I could do 0.05, 0.1, or I'll put quotes here so it stays up there. I could do the same thing, but I could do from the left end mark. So remember, we're looking at if 90% in the middle, we have to have some cutoffs on our normal distribution. I'll put a page up of notes graphically that shows those pictures up, shows some pictures up there so you can see them. So that's how you would find those. So for 90%, I think our values were 1.64. I think I'm going to put those somewhere else though. I'll put over here. So this is my Z that I would have. Okay, let's put the Z-score here. So it's on this page. And that would be 1.64. And then if I did a 95%, then I would do a norm inverse 0.025, 0.1. Or I might do a norm inverse of 0.975, 0.1. And that should give us a 1.96. And then if I did a 99%, so this was all in the slides last week on the Excel sheet that I was running on. So you can pull that up from last week's video also. But these are probably the ones that you're more likely going to see. 0.005, comma 0, comma 1. And this one would be norm inverse 0.995, comma 0, comma 1. And that's like 2.58. So I have a Z. So mine was a 90%. My Z, 90% confidence level. So I'm going to have a 1.64. So if I want to make my confidence interval for the population proportion of people that would drink bottled water, I would start by putting in my point estimate. I'm going to do the +1 first, then I'm going to put in my z-score, multiply that times the square root of my p times 1 minus p, and notice we already did the subtraction there, so it's already taken care of, divided by the 1361, which is my n. Notice that I didn't have any extra parentheses there. All the multiplication and division inside those parentheses will be done in the proper order. So this will give me my upper value. And then I can copy all that. And I'm going to get my lower value here by putting in the minus. And change this to a minus, and then I have my interval. So now I have an interval from 0.616, comma 0.658. You could see it that way, 61.6% up to 65.8%. Probably the only a couple different ways. Yeah, that's for the most part, that's the way you're going to see those from me. So it's a confidence interval for the population proportion. So we are 90% confident that the true population proportion of people that will drink bottled water over tap water is between 61.6 and 65.8%. So there's your first example using the confidence interval for confidence interval for the population proportion. So the second problem is looking at the voting in Johnson County. So let me go back to my slides here. We'll take a look at this example. A couple more here. So true proportion, we support a 15-hour wage increase, 65%. We took a sample of 805 likely voters in Seattle, 95% confidence interval. So we have some values. So let's do this as number 2. So we had a P of 65%, so 0.65. 1 minus P would be 0.35. I did it on a calculator or in your head. N was 805. My Z, I need a 95% confidence interval. So I'm going to go back up to my Z scores, 95%. It's my 1.96. So 1.96. And that needs to be a Z over there, not an X. And let's see, was that the only things I need? I think that's all I needed. So now I can put things together. So I start with my point estimate. Put in my z-score times my square root of p times z divided by, or not z, p times 1 minus p divided by n. And that, this is the addition one, so this should give you my upper value for my confidence interval. And then we'll change that to a minus sign. And that should give me a lower value for my confidence interval. So we had an interval from 61.7% up to 68.3%. We are 95% confident that the interval from 61.7% up to 68.3% captures the true population proportion of voters who voted yes. So you can see this is a good example of what you might see in a polling situation where they ask yes or no questions. Did you say vote for A or B? Did you vote yes or no? It can't be if you have more than two, it gets a little more. It gets a little trickier. It gets a little more tricky in terms of building up those confidence intervals. But when you have two choices, it's pretty easy to build that confidence interval. So you've probably seen polls like this. This one you could, if you wanted to look at just the margin of error piece, remember that is the part that comes at the end after the plus or the minus. Okay, so the part I'm pasting here is identical to either one of them. Okay, and this is that margin of error. And so that margin of error in this case is about 3%. So you might see something like 65% plus or minus 3%. That's what you'd be more likely to see in a poll if a poll was published on TV or a newspaper or a magazine online. That's what you would probably see in those cases. Okay, one last example. So this one, I think we've got to calculate our percentage this time. So if we jump back to our example here, we have a 250, so that would be your N. 98 report owning a tablet, so there's your numerator. So 98 out of 250 is going to be our P. And we have a 95% confidence interval. So we're going to estimate the true population proportion of those who own a tablet. So we're number 3 here. We're going to have P, 1 minus P. N was 250. We have a Z, confidence level 95%. We already know that. We already did it on the last problem, but you can go back up and look at the table. I'll post this. I'm going to post this spreadsheet also. Up here, we would do, I'm going to type it here, 98 divided by 250. That's how you type it into Excel if you wanted to calculate that p-value. So we're going to go with the 0.392. And then here I can just do a 1 minus 0.392, and I can get its value. So now again, I have my values. I can make my confidence interval. So I would do 0.392 plus 1.96 times the square root of 0.392 times 0.608. That's 1 minus P divided by my N. Again, this would be my upper. Now let's copy and paste that so you can see that value. And then we're going to change the plus to a minus. And plus to a minus, and there's my interval. So maybe I see something like 0.331, comma 0.453 as my interval. So again, we're 95% confident that the interval from 0.331 up to 0.453 captures a true population proportion of people who own tablets. So confidence intervals for proportions. You do not need to worry about whether it's a t-score or z-score. Now on the quiz, you'll have to be concerned because I believe I'm looking at the quiz right now. That's the first 6 questions all deal with proportions. Okay. The 7th question deals with means. So make sure you're reading. Okay. And then the last couple of questions are more, 2 of them are about the Z or T, knowing when to use which one. And then the last question is one I always ask. I collect data on it. It's just interesting to see how people answer this question. There's only one wrong answer. I just like to see how people are going to answer that question. So tonight you'll see quiz 9 go up. I have a bank or a review in the review section on content. Under reviews, you'll see reviews for 5 through 8. You'll see solutions for the review 5 through 8. And then you're also going to see posted your multiple choice tests 5 through 8. And this is the normal schedule that I would have run anyway. The only difference is we're not meeting face to face. And so you've got a busy week in terms of getting those things done. Next week, I'm going to send out directions sometime tonight or tomorrow about how I want to do the written part. I'm looking at give you a couple days to choose from, and then you're going to have to choose a window of time. It's only front and back. It's about 7 or 8 questions. I'll probably give you about a 2-hour window. And so I'll email the test questions directly to you. You can do them on a piece of paper. You don't have to print it off. You can just do it on a piece of paper and then take a couple quick pictures of it. And then you email the pictures back to me within those 2 hours. That's how I've typically done it. I've had to do this a few times. I had a lady that had a baby last year, and it worked out for her. I've had other people had to miss for work. I just structure you to those 2-hour windows because I don't want you to have it for 3 days and keep working on it. So we'll restrict you to those 2 hours. But it doesn't have to be during the scheduled class time. It doesn't have to be, if you do it at 2 a.m., it's going to be a little tricky for me to get it sent to you because I'm probably not going to get up. But so think about your time next week. I'm probably going to look at either Tuesday and Wednesday next week of doing that. Next Tuesday, I don't have a video or anything to post like this. I would probably, I would like to have some, maybe just I can set up maybe a Zoom waiting room where you could log in, give you a link, and you could ask individual questions for part of the review, or I can just do an open meeting. I don't know. I'll have to look into Bright Spaces. I heard it wasn't that great, so the video chatting part of it. But if you feel comfortable, if I have a Zoom with a password, and as long as you don't share it out, we should be okay. But I'd be willing to look into doing that. So I'll probably send an email and also asking if you'd be interested in that. And if I have enough people, then we can set up something and do kind of a Zoom review if you need to. The final you'll come out next Tuesday, multiple choice section first, and then I'll have the same scenario for the next week. If anybody needs their grade right away for graduation, that's an important thing to let me know. I don't think we should be okay in terms of time. I think grades are due sometime sometime after the 14th. I would like to have, and I'm sorry, the 21st. I would like to have those done by the 24th. So again, the final probably the 21st and 22nd. I'll give you that same option. You pick the day, you pick the time, 2-hour window. Again, no major. I don't think you don't do any graphing. You don't do any scatter plots or box plots or anything like that. So should be pretty straightforward. Main thing for you as a student is to email me questions. Okay. Don't be afraid to ask anything. If you're stuck, let me know. I'll guide you through it the best I can. If we need to video chat, let me know. We'll figure out a way to do it. I've got options. I can set up a Zoom. We could set up a Google, maybe a Google Hangout, or I think it's a Google Hangout. That's what I've been doing at school. Just let me know. Again, the communications are very important. Keep working on your projects. If you got questions there, you got to send them to me. So make sure you're communicating those questions. Don't wait till last week to get everything. Try to finish everything up. If you got special circumstances, let me know. And then if we need to communicate with the Mount Mercy, I can do that to get some guidance there. But again, communication is very important. So let me know. And if you got questions, definitely let me know. So you'll find the video, quiz solutions will be up. All that stuff will be going up around 5:30 tonight. So have a good week. Be safe. And we'll talk to you next week.